Hello everyone, welcome to this session on advanced control techniques of electric drives. So in this video, we will discuss about the direct arc control, which is commonly known as DTC, which is used in the AC drives. And this is the part of our unit 4 for the third triple students in the subject electric drives and controls. Let's begin by understanding the concepts of this ADC as well as its working. So let's quickly recap different control methods. We have already discussed about the scalar and vector controls. So in the scalar control, we can also call it as a V by F control, which maintains the constant voltage as well as the frequency ratio, but lacks the precisions here. And next we have discussed about the vector control or field oriented control, which separates the torque and flux components for the better control. Finally, we are going to discuss about the DTC, which is direct torque control, which directly controls the motor torque without using a modulator, which results in a much faster responses. And this mind maps provides the overview of direct torque control. So it highlights the working steps, control loops, and performance features. So this mind map will help us to go through each stage of this DTC process. Next, how this DTC will work. This direct torque control uses two control loops along with the advanced motor models. So it continuously predicts the stator flux and electromagnetic torque. Next, the motor current and the DC bus voltages are measured and processed using the algorithms. So these calculations are performed very fast, typically every 25 microseconds, which ensures the real-time control. Next is the two control loops of these DTCs. So the DTC mainly operates using two control loops, which is that is one is for the torque, another one is for the flux. So these loops work together to maintain the desired motor performance with high accuracy and speed. Next, we are entering into the steps which we are following in the DTC. So step one, which is the measurement. So in the first step, important parameters are measured. Two motor phase currents are sensed. So the DC bus voltage is measured. Switch positions of the inverters are monitored. Using these values, the motor voltage is determined for further proceedings. And second one is the motor model processing. So in this step, the measured data is fed to the motor model. Advanced mathematical algorithms are used to compute the stator flux, torque, as well as the speed. So these calculations are done extremely fast. Sometimes it can be done within 12.5 microseconds, which ensures the precision control. Next, step 3 is the comparison. So here the actual torque and the flux values are compared with the reference values. So the comparator maintains these values within a small hysteresis band. This also ensures the quick torque response without overshoot and improves the system stability. Next, the fourth and fifth step, which is the pulse selection and the switching. So in this stage, the torque and the flux status signals are sent to the pulse selector. So a lookup table which we can use to choose the appropriate voltage vectors. So based on this, switching pulses are generated and applied to the inverter in order to monitor the motors. Next is the speed control loop. So the speed control loop includes a PID controller and acceleration compensator. So it generates the torque reference values, the flux references controller, which also determines the required stator flux levels. This ensures the efficient and stable motor operations. Next, we can go for the comparison with the DTC versus FOC. So compared with the field-oriented control, DTC has some advantages, like it does not require speed or position sensors, make it more simpler and reliable. Also, it eliminates the need of PWM modulation, which results in faster torque response, typically less than 2 milliseconds. Finally, we are concluding with the advantages. So DTC offers several key advantages. It provides extremely fast torque responses. It can produce a full torque even at zero speed. and processing is much faster compared to traditional methods. It ensures the accurate torque and speed control even at low speeds. And these are some of the references which we are used for this topic, and which includes also the textbooks, NPTEL and MIT OpenCourseWare. So you can explore these materials for deeper understanding. Thank you for watching this video. Thank you.